So we're going to finish by identifying conics, which is basically the same way that we started. We started by looking at what the different things were. So we're going to actually summarize the whole unit in this section. If you need, these are the formulas right here, okay? But I'm just going to quickly just review each one. So I'm not going to keep turning back to that reference page, but I am just going to quickly talk about each one. And again, this is just a review, right, of everything we've done. So when we looked at circles, how did you write the equation in circles? You had x minus h squared plus y minus k squared equals r squared. And again, you can get that straight from the formula, or you can go back to circles and get it, where h and k represents the center and r represents the radius. So right here, hk is the center, r is the radius. So this is what it is in standard form. So we're just going to summarize everything because they're going to mix up the question. So you need to know how it is. So if I slice it this way, it's going to be a circle. If I slant it ever so slightly, it's going to be an ellipse, right? And remember, you can have a horizontal ellipse stretched this way. You can have a vertical ellipse stretched this way. So the standard form for a horizontal, remember, for horizontal, for an ellipse, a squared is always the direction for just an ellipse, the direction that it's stretched. So if this is stretched horizontally, a squared must be under the x because it is stretched in the horizontal. If it's stretched vertically, a squared is under the y value, okay? And the way you write that, once you know where a squared is, it is always going to be x minus h squared plus, and this is very important, it's plus y minus k squared equals 1. And then the fractions are, for this one, a squared has to be under x because it's stretched horizontally. So for ellipses, where the a is, it tells you the direction. So a squared, which means this is b squared. For this one, it's just like a circle. So this part was a circle. So the x minus h squared plus y minus k squared equals 1. Only because it is stretched vertically, that a squared has to be under the y value. So again, in ellipses, I guess I can just write here, a squared determines I guess direction. All right, a squared determines direction, just like a circle. So it looks very similar to this, only we have fractions and r is 1. Okay, so a squared is what you look like for ellipses to determine where to put the a squared. It determines on whether it's stretched horizontally under x, vertically under y. Now, the reason I emphasize that is when I come to hyperbolas, it's very similar to ellipses. The only difference is the negative determines the direction. Okay, so again, just like an ellipse, you have horizontal, and if you look right here, if it's opening to the left and to the right, okay, that's horizontal. If it's opening up or down, that's vertical, right? So the difference being a squared no longer tells me direction, the negative does. And the only difference between these two formulas, so I'm going to copy these two formulas. The only thing I'm going to do I'm not going to put in the letters just yet. So I'm going to copy down the two formulas. All right. Instead of having a plus sign, you're going to have a minus sign. Okay, so this negative is going to determine direction. And the way you need to remember this is the negative, all right, goes with the opposite. All right, so in this case, direction, I think, is x, right? Because it opens left and right. So this means it goes with, y. Which means as soon as I know where the negative, that's when I can start writing this equation. I cannot start writing this equation just because I'm given a, like the last time, right? So here, a determines the direction, but here you must start with the negative first. Once you have the negative, so y is negative, that means y is negative. Y goes here, which means x must go here, right? So minus the center, so like before, h minus k. Now, this is very, very important. It does not matter whether it's horizontal or vertical. A squared is always under the first one. B squared is always under the second one. And what you do is when you're trying to determine what A is, it is the one that's in the X direction. If you're trying to determine what B is, it's in the Y direction for a horizontal hyperbola. Okay? Let's take a look at a vertical one. So if it's a vertical hyperbola, right, I would think it's vertical, but the negative is with the opposite. All right, I would think it's Y, but the opposite is X, so it's with X. So pay attention to how I'm going to write this. Instead of this being Y here, the negative goes with X. So this is X. So the negative first, then it determines what is X and Y. So that's X. This is Y. So again, minus the center, minus H, minus K, or in this case, the vertex. All right, and then the position of A squared must be first. Doesn't matter. So in this term, A goes with Y, B squared goes with X. Okay, and in terms of definitions, that means that A is in the Y direction, which means from here to here is A. That's what that means. All right, B is in the X direction. That means from here to here is B. That's what that tells you. So if I did the same thing here, A is in the X direction. So from here to here is A. B is in the Y direction. From here to here is B. And immediately you can see A is always my vertices, right? So this is my vertice, this is my co-vertice. A is always my vertice. Right here, this is my vertice, this is my co-vertice. A is always vertice. Okay, so this is the major difference between these two, is that this is plus, this is minus. In this one, A squared determines the direction. So in other words, whatever it is, whether it's horizontal, okay, so this means if it's horizontal, A has to be under X. If it's vertical, A has to be under Y. In this case, they're going to stay in this fixed position, A squared first, B squared second. A squared first, B squared second. Doesn't matter what direction they are. Then what determines direction is the negative. So you first have to put the negative, and then it will tell you which one is A, this is X, and here, this is Y. All right? So that's the biggest distinction between those two. With terms of the isotopes, the formula for a horizontal one, yeah, this is horizontal. The formula for a horizontal, you just need to know that your slope for a horizontal one every single time is B over A. For a vertical one, your slope is the opposite, A over B. Once you know that, the equation is the same thing with just the slope being different. So the equation of an isotope is Y equals plus or minus the slope, which is B over A, X minus H, always about the center of the vertex, plus K. All right, so here it'll be Y equals the slope, which is A over B, so plus or minus A over B, X minus H plus K. All right, and we proved those when we actually talked about hyperbola. So I'm just giving you a quick reference. Now, the formula for C for both the ellipse and the hyperbola I left to last because I want to show you the difference. When you're dealing with an ellipse, it's C squared equals A squared minus B squared. When you're dealing with a hyperbola, it's C squared equals A squared plus B squared. All right, finally in a parabola. Now, you've done this extensively in Algebra 1, Algebra 2, but I just want to make sure you've seen equations like this before. -5, for example. This is a parabola in standard form. And notice, this is what you're used to, right? You have an x squared. So the x is squared. So these are the kind of parabolas you've dealt with before, whether it's up if A is positive, or down if A is negative, up and down. So anytime you see the x squared, you're dealing with an up or down. So don't write that down. I just wanted to give you a quick reference. So let's go ahead and put it here. So this is up and down. It's what I'm normally used to seeing. So the squared term, square is with x. Okay. The squared term is with x if it's up or down. All right. So, and I'll do the square here is with y. So this is not usually something you're used to seeing. If it opens to the right, or it opens to the left, the square term is with the y. And that's what you look for. So the general form is going to be, so the squared is with the x, so I'm going to put that first. So x, okay, minus h squared equals, in this case, with it being in the y, instead of it being x, because the squared term is with the y, it'll be y here, minus h. Okay, so again, I just want to compare the two. Squared term is with the x, it's up and down. Squared term is with the y, it opens to the right or opens to the left. All right, and then it is 4p, okay, 4p, where p is the distance from here to here or here to here. So this is p and this is p, okay? 4p is also the distance from here to here. So we have special words for this. And again, you can just turn the page. I'm just giving you just a quick summary. So 4p, parentheses, and this is always the same. So equals 4p. So the only difference between these two is literally right here. 4p, and because I use the x, this is going to be y minus k. And because I use the y, it's x minus k. All right, so that's how you identify conics, right? So these are the equations, right? So when you come over here and it says, okay, well, how do I identify if it's a circle, an ellipse, a hyperbola, or a parabola? You're going to follow this flowchart right here. So I'm going to show you how to do this. The question is, are they both x and y squared? If yes, go this way. If no, go this way. So the best way to do this is, of course, to look at an example. So let's take a look at example 1. Okay, so are both x and y squared? So here's x and y. They are squared. So I'm going to go yes. If it wasn't, it would be a parabola. Okay? So if they're not squared, it is a parabola. Why? Because a parabola's general form only has one thing squared, not both of them. Okay? That's why. All right? So if it's yes, it could be one of the other three. So it is squared. So I go down here. Are the squared terms being subtracted? If they are, it's a hyperbola. Why? Because the squared terms here are going to have a subtraction sign. If it's not a hyperbola, so let me look here. Are these being subtracted? No, these are both positive. So in this case, it's no. Okay. Are the coefficients of the squared terms the same? So let's look at them. If these coefficients are the same, then it's going to be a circle. Okay. Why is that? Because you're looking at this right here. It has no fractions, so these are the exact same thing. Just the squared terms. Okay, so if it's yes, it's a circle. If it's no, it's an ellipse. So in this example, yes, they're both squared, right? They're both squared, so I go yes. Are they being subtracted? No. Are the coefficients of the squared terms the same? Are these the same? No. So this must be an ellipse. So even without me doing anything, I know that this is an ellipse. All right, so I go look at this term right here. All right, so ask the first question. Are they both squared? Yes, they are. So it's not a parabola. So I go yes. Are the square terms being subtracted? Are they being subtracted here? No, they're being added. So no, because if they were being subtracted, it would be a hyperbola, so no. Are the coefficients of the squared terms correct? Meaning, next to the x squared and the y squared, are those numbers the same? Yes, they are. They're both invisible ones, right? So yes, that is a circle. Use the flowchart to complete the last two examples. Let's practice.